of doing it. So, okay, so modeling data using exponential functions. All right, so the 7.3 is just dealing with, so we may as well do an example together. Punch into your equation. We're just modeling it and using our regression. So for year 1951, 61, 71, as opposed to using the year, I would suggest that you start as 51 being 0 and maybe go up by tens, and let's see if we can get it to work that way. All right, so let's try this a couple different ways. Well, let's start with 1951. We'll start with that to begin with, and then we'll go from there. See if you can get it to work. I'm not sure it will. With,
I did yesterday.
and it worked? Okay, beauty. So 1951, 1961.
So you want us to do it like the 0, 10, 20 thing, or just do it 1951, 61?
Do exactly as it's printed. Okay. Everybody got minutes, line 1 and line 2? Yeah? Everybody's in?
One more.
One more? Okay. We have to make sure we do this all as a group here so that we know whether or not we're going to get this right. So go to your solver screen, so second function quit at the top, second function mode. So go to your solver screen. Now how do I pull up the regression? Stat, calculate, it's 0. And then what do I do next? L1, L2, bars, Y bars, Y1. Yep. And then hit enter, right? So it gives me the equation. Now I haven't gone over to my y equals yet, but it looks like it's is that what?
No, that's not the right answer. That's not right.
That's not the right answer, right? Okay, so let's go back.
It'll go all the way down. Most of that is right here. And that's the little box.
Okay, so let's go back and see what happened. So 1951, 61, 1971, 81, 91, 2001, 2011. 776.5, 921.7, 998.9, 1035.5, 1109.6, 1251.4, and 1250.6. I think all my numbers are right.
It's real close to what they have.
Okay, well let me try this now. So I don't know. This is what you have, right? So this isn't what.
So I got 8.45.
Yeah.
So I got times 10 to -4.
That's,
And
yeah.
then point 1.
No one plays.
Okay, well let's just. And that everybody has that 8.45.
No,
Yeah.
What do you have?
828.430.
Okay, so.
39. I don't know.
Okay, let me do this. Actually, this might be a problem. Mode.
This is the 1951, 1961.
I'm still getting 7.9. Okay.
Hmm.
Read your, sorry, 1951.
Yeah.
1961, 1971, 1981, 1991, 2001, 2011, right?
Mhm.
776.5,
Mhm.
921.7, 989.9,
No, 998.
998, there it is. Point
9.
9. Okay, so let's try that again, so a bunch of quick. Easy to make errors. There you go, I got 8.45. Alright, so let's change this. 8.453, right? 10 to the negative 4, and then 1.007. Got that? Dylan, no?
I got 8.42.
Okay.
I don't know.
Shane, you're checking the numbers?
Yeah.
So one of those numbers probably on the column 2 is off.
Probably a decimal.
Okay, so now, everybody go to y equals, please. Yeah.
Where did you get the 10 to the negative 4?
It says e negative 4 on mine.
Oh, okay.
You see it there?
No.
Okay. All right, so go to y equals, please. Everybody's at y equals? Go to the top, turn your stat plot on. Okay, so far? So it should be just go up to it and hit enter on. Everybody's okay?
Okay, sorry, say that again.
Go to y equals.
Okay.
And then stat plot at the top. So you just hit enter on it, okay? Now I'm gonna graph. So of course it's not gonna graph, right? So now what? Go ahead. No. Yes and no, I suppose. Go ahead. Dino.
Sorry, what do we do? Because I had
Y equals,
Y equals.
and go to the stat plot at the top and turn it on.
Okay.
Okay? So what do I do now when it doesn't graph? I zoom, no, not fit either. No. What are we doing right now? When I plot points, what's that called? What did I use on here? To get my points plotted. Stat. Okay? So I zoom stat it. And that will automatically give you points and your regression line. Okay, so go to zoom stat. Second from the bottom, it's zoom 9. Everybody get a graph? Zoom stat. Now, okay, so I have adjusted my window, so you were right, Courtney. I do adjust my window, okay? But if I zoom stat when I'm in stat plot, it works immediately. Okay, now what I would do is I probably would zoom out myself. I'd move to the far right and zoom out on it just to get a better picture of it. Because right now it almost looks like a straight line. Is that right? So I'm going to go way to the top right corner here, and I'm going to zoom out on it just once, and then it kind of puts all my points really close together, and then I can at least see the curve. Any problems?
It does not look like that.
Ooh. Yours does not. Oh, okay, so you don't have your equation in here, that's part of the problem. Okay, so in order to get your equation in there, you go, it's not sure where, let's hit enter here. There. You have other information in here somewhere. What's going on? Okay, first one was
Really many broke off my legs like fucking
As enter? Yeah.
No. Oh no. Yeah.
This is a different type of graph, this is a line histogram graph, where you actually connect the dots. Okay, so that's, so they're, now. Yeah, so then I would go zoom out right here, and I go all the way across. I don't know, all the way up here. Okay, so we got that one straight, everybody else is good? Got your curve through, looks like through your dots, right?
Yeah.
But if you actually zoom in on it, you notice that it doesn't go exactly through. So here's the thing with your regression graphs, is it's giving you an approximation line. It's giving you an approximation line on it, right? So it goes through it basically is an average of the dots. Okay, so now, use exponential regression to define a function that models the data. So there's my equation. So I use my exponential. Assume the same growth as in part B, estimate the population in 2020. So I want to know the population in 2020. How can I find it?
Calculate value 2020.
Let's check it and see. Does it work? What did you get?
1,349.525.
Everybody get that? Not get that? You may not get that. Okay? Assume the same growth as in part B. Estimate the population when it will reach 1.5 million people. 1,500,000. How do I go about this guy?
Make another line.
What do you mean?
You put y equals whatever 1,500,000 divided by 1,000 is.
Beautiful. You guys are doing great work here. Okay? And I hit graph, and then
Can you please tell me what
sure. That's why I went, right?
Yeah.
Okay, and then find my intersection point. And what year will it be? 2034.95, so almost 2035. It'll hit 1.5 million people. All right? Has everybody got that?
I was like a little bit off on the,
What did you get?
which one? I got 36.
2036?
Did you trace it? Or did you put the model?
Go second function, trace, okay? Go to intersection. Hit enter 3 times.
Yeah, that's why.
Kayla, did you get it? Let me see. Okay, yours is slightly off as well. I'll hit enter, I guess. One more time. Now did you get the exact number?
It's still 2025.
Okay. No, okay, do that again. Go second function, calculate. Second trace, intersection. Okay, we good? Yay?
Yay.
Alright, that's all 7.3. That's all you're doing for 7.3. It's not a very long one. Okay, so, any questions actually about that, or even 7.2 for that matter? Dylan, are you getting this, or are you not?
Yeah, no, we know.
You good? Okay, I'm gonna move on to this logarithm now, okay? And I need you to, this is hard. I can teach it to you and just show you the exact same process that you just did with exponential, and everything just flips because it's an inverse graph. But I think it helps a little bit to understand what logarithm is. Okay? Now in pre-calculus, you're gonna do a whole unit on this, and it'll make perfect sense. But in this class, they don't explain it all that well as to what it is. Okay? So I'm going to explain it to you a little bit here, more in depth than what we need, and then I'll explain the graphing to you, and then it's pretty easy to do because it's just exact opposite of the exponential graph. It's called the inverse of it. Okay? So, first things first. 4 to the x equals 16. What does x equal?
2,
2? Okay, how do you get 2?
because 4 squared is 4 to the power of 2 is 4 squared, and 4 times 4 is 16.
Okay, so I get this. 4 to the x. So what I do is I make sure that the base is the same in both cases, correct? This is what, okay, again, base is this number, exponent is that, right? We all understand that? Okay, so I change it so that this is the exact same base, right? So I get this. We all agree? So far so good? Okay, great. That's it. 8 to the x is equal to 32. Okay? What does x equal?
1/2. Or no, -1.
-1?
No, -2.
Okay. -2 is a guess. Anybody else have a guess? Alright. What did I do in the top question? I made the bases the same. Can I make these bases the same?
Yeah.
Yeah? What do they have the same common base as?
You could use any number.
No, I can't.
Like you could do 8, 4.
Can't. Nope. No, I can't. What's the one common base between the two?
8.
No. 8 doesn't. 8. I can't have a multiple of 8. So I can't take 8 times something and get 32. So I can't times 8 by itself a number of times to get to 32. That's what I'm saying. Okay, so let me make this simpler for you. All right? 8 can be broken down to what?
4 and 2.
4 and 2, and 4 can be broken down to
2 and 2.
2 and 2, so it's 2 times 2 times 2. We all agree? So 8 is actually 2 to the power of 3. Yeah?
Yeah.
Good. That look right?
Yeah.
2 to the power of 3 to the x. What do I do when I have an exponent to the exponent?
Add them. Multiply.
Which is it?
Add, isn't it?
Okay, let's review. All right, this is. What is that?
2 to the power of 6.
2 to the power of what?
6.
How many 2's do I have here?
2.
How many 2's do I have here?
3.
Is that 2 to the power of 6? 2 to the power of what?
5.
What do I do when I have this? What do I do with the exponents? I add them, correct? So then if I have, what do I do with the exponents? Add them? Okay, what does this mean to me? What does that mean to me?
Squaring.
Nice and loud, nice and loud.
2 squared times 2 squared times 2
It
squared.
means 2 squared times 2 squared times 2 squared, does it not? 2 squared to the 3? Yes? How many 2's do I end up with? 6. What do I do when I have an exponent to an exponent? I multiply them. I'm not going to do the same thing here and here, am I? No. Right. So I multiply the exponents. Dylan, put that calculator down. You need to pay attention to this. You're the one that's not going to know these rules. Okay? So 2 to the 6. So now let's go back. What do I do with the exponents here? Multiply them. So now that gives me 2 to the 3x. We agree? 32. Can it be broken down to 2 to the power of something? 2 to the power of 5. So now I have common bases, do I not? 2 to the power of 5. Everybody agree? So in order for these two sides to be equal, if the bases are equal, what does that mean that the exponents have to be? They also have to be equal. In order for the left side to equal the right side, if the bases are the same, then the exponents have to be the same. Agreed? So that means then that 3x is equal to 5, x is equal to 5 over 3. 8 to the power of 5 over 3 is the same as 32. Okay? This is all grade 10 math. Grade 10. I'm scared to go to grade 12 math. Because we don't remember this. Okay? Everybody understand what I'm doing here? Yay, nay?
Not really.
Not really. So you're paying attention to your calculator instead of the board. Okay. 4 to the, oh, let's not use 2s and 4s and 8s again. Let's do this.
Okay.
At least write down 2.
No. 27 to the x is equal to, oh, well, let's make it simple. 81. Dylan, I need to solve for x here. The only way you know how to solve for x is to change it so that the bases are the same on both numbers. That means that I have to take some number to the power of something and get 27, and that same number to the power of something will also give me 81.
Okay.
So what can I break 27 down to?
9.
3.
9 to the power of what?
3.
Seriously? 9 times 9 times 9 is 27?
Oh, I'm really bad.
You
No.
can do 3. Let's do 10 simulation.
What can I do?
3 cubed.
3 to the power of 3. Does that give me 27? 3 times 3 is?
9.
Times 3 is? Okay. Dylan, you following this?
Yes.
So that's 3 to the 3 to the x, which is that. We agree? Because we multiply the exponents. Everybody's following here. Because if you can't, we're going to really lose you here. 81 is what?
The 4.
Pardon me?
3 to the power of 4.
Did I hear that?
No, I'm just checking if it was right.
Checking to see if my math is good. Is that
No,
what
my
you're doing?
math was good. Because I thought it was
3 to the power of 4 equals 3 to the 3x. What does x equal?
1 1/3.
Okay, let's just do it
4
simple.
over 3.
4 over 3. Right? In order for these to be the same on both sides, if these numbers are the same, what does that mean for the exponents?
These things.
They have to be the same, right? So 3x is equal to 4, x is equal to 4 over 3. Everybody following?
Last if I'm understanding.
Dylan, in order for the left side to equal the right side.
Okay.
Right?
Right?
If this number and this number are the same.
Yep.
Then that means that in order for this side and this side, this has to
Okay.
equal this,
Okay, yeah.
right? So that 3 to the x has to equal 4 in order for the left side and the right side to be the same.
Gotcha.
Fair enough?
Yep.
Okay, so let me just prove it, okay? So if x is 4 over 3, that gives me 3 to the 3 here, right?
Mm-hmm.
And 4 over 3. And I multiply them, right? What's 3 times 4? What's 12 divided by 3? So this is the same as 3 to the 4th. You agree with me? Which is also the same as 3 to the 4th over here. Everybody okay? Because I'm about to wow you right away here. Everybody's okay? You good? Sure?
Yeah.
100% sure?
Yes.
Here's why we use logarithms. I need to be able to solve this. 3 to the x equals 8. Casey, wake up. 3 to the x equals 8. I need to be able to solve this. Can I get them to the same base? Is there a way that I can get 8 to the base 3? No, I can't, can I? How then do I solve a question in which the bases are not the same? There's no button on here for that. There's no button. I can't square root. I can't take the nth root. I can't. What do I do? Well, this is what logarithm allows us to do. It is a button on the calculator, as it turns out. Logarithmic. But what it allows me to do is I can now take the log of both sides and I can change the base so that's all base 10. Now again, I'm going to speak a different language to you and it doesn't matter for right now. In grade 12 pre-calc next semester, you will know what I'm talking about. But I'm just going to show you this right now. So what I have to do is I have to go, do not worry about this. You are not being tested on this. You don't even need to know this until grade 12 pre-calc, but I'm going to show it to you. So if I take the log of both sides, all right, it's like me saying, okay, divide both sides by 2, times both sides by 4, add 6 to both sides, all right, square root both sides. It's just a function. Log is a function that allows us to what we call change the base so that they are the same. So I do this, and here's the quick math on it. My rule says I move that to the front, so I get x log 3 equals log 8, and then x is equal to log 8 over log 3. So what I have done, that logarithmic has a base of its own. You can't see it because I didn't write it. But what you will understand in grade 12 pre-calc is that that base is 10 right now. I've now switched to the counting base 10. So now when I punch this into the calculator, I can go log 8 divided by log 3, and that'll tell me what x is. Okay? Now, we don't need this for grade 12 apply. We don't have to do this. It's not hard. I promise you this will be very easy for you once you learn your exponent rules again. Okay? This will become very easy for you. So what do we need this for today? Well, we are going to graph the log function. Y equals log x. Okay? So that is what we are working to right now. We are working at going into this. First things first. What are the 4 characteristics of an exponential graph? Again, sorry, I missed that.
Number of x intersects.
Number of x-intercepts is?
0.
0. Doesn't cross the x-axis, does it? Y-intercept is?
Whatever you're
1. Y-intercept, we'll just go with the standard one. Y-intercept is 1. So let me do this. F of x is equal to 2 to the x, okay? So we'll have that as our graph. y-intercept is 1. We all agree? When x is 0, what is y? 1. Correct? Okay. What else do I know about this graph? End behavior is 2 to the 1. And what do I have to add into that a little bit? Increasing bit. So it goes like this, right? Okay? Yeah? Domain?
X is more than 1 real.
Y range, right? Y is greater than 0. Okay, everybody's okay. Now I'm going to test your ability again. Those of you that were in pre-calc last year, you should know this, but I'm certain you have forgotten this. What does it mean to take the inverse?
That's when it's at 1, isn't it?
What does it mean when it takes the inverse of a function? What do you do to find the inverse of a function? Does anybody know that, what I'm asking? Okay. Let me put it to you a little bit more in layman's terms to begin with. What is the inverse of multiplying something? Divide.
Divide.
What's the inverse of adding something?
Subtract.
Subtracting, right? Okay, so when we talk about inverse, that's what we talk about. But in graphing, when we talk about inverse, we talk about switching your x and your y. Okay? So if I took a table of values, I switch my x and my y. Does everybody understand what I'm saying here? Okay, so what is going to happen here is this. I want to graph I'm going to put this in here because that's my base. The inverse of an exponential function is logarithmic. Again, it doesn't need to make 100% sense to you. You just need to know how to actually do it. So what that means is this. Let's take a table of values now. And then we'll graph it, and then you'll have a good understanding of it. Okay, so here's the table of values. Let's use this as my equation here, okay? So I've got x, y. Minus 2, minus 1, 0, 1, 2. Okay? Just going to use those values. So I substitute them into y equals 2 to the x. 2 to the negative 2 is? Think back to yesterday. What is 2 to the negative 2? Close.
8,
No. Just 8.
2 to the power of negative. Okay, let's start the other way. What's 2 squared?
4.
2 to the 1?
2,
2 to the 0?
1.
2 to the negative 1?
0.5. And then that's
2 to the
1
negative 2?
over-
Oh,
If you're looking back.
So let's remember
Mine's at least 24 hours ago, right? Okay, so everybody understands this part of it, right? When you have a negative exponent, you make it positive by putting it on the bottom of the fraction and then finding your value, right? Everybody remembers this from yesterday? Okay, because I can't go into today if you don't remember it yesterday. Everybody's okay with that? So a negative exponent, put it on the bottom of the fraction and make it positive. That's it. Got it? All right, so here's what today is. Today is taking the inverse of this graph. And by taking the inverse, I switch my x with my y. So what that looks like as a coordinate is it becomes this. xy becomes yx. Okay? Everybody following me so far? So now when I graph it, instead of minus 2 1/4, oh, let me do this in a different color so it makes sense. This is my new graph, which will be the graph of this guy. So it'll be 1/4 negative 2. 1/2 negative 1. 1 0. 2 1. 4 2. So when I graph that, Everybody understand this? Just switching my X and my Y. Okay? So now when I graph it, it looks like this. Like that. That is the graph of y equals log x. In this case, base 2. Okay? Now there is one other part of inverse I haven't explained that I would explain in greater detail to you in pre-calculus. And that is this. Inverse, okay. Inverse is a reflection, meaning a mirror image. Okay, that's what reflection is. It's a mirror image over the y equals x line. So what that means is this, is if I took a line and I drew a y equals x line. So that's the line y equals x. All I've done is I take this and I flip it over that line and I get my new graph. Okay, so far? Does everybody understand that? Again, we go into great detail on this in grade 12 pre-calc. Okay? When we measure earthquakes, they use a scale. What's that scale called? It's called the Richter scale, right? And so they say it has a magnitude of 4.0. The earthquake has a magnitude of 4.0. The earthquake has a magnitude of 5.0. What does that mean? What does that mean? Anybody have any idea? Well, the Richter scale is done on a base 10 level. So if you go 4 to a 5, it's 10 times greater, the earthquake. This is what they use. They use exponential and logarithmic graphs in order to do it. So their scale of 0, 1, 2, 3, 4, 5 along the bottom means 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5. And so it's 1,000 times 10 to the 3 is 1,000 times greater than 10 to the 0. Okay? So this is where you would see this in everyday life when they talk about earthquakes. But it has nothing to do with your math right now. All you need to know is what are the characteristics of a logarithmic graph. So looking at the four characteristics of a logarithmic graph now. What's characteristic number 1? X-intercept is what? X-intercept is 1. It's a mirror image. It's right there. Right? What's the domain for this graph?
X is greater than 0.
What's the range for that graph?
Y is an element of all reals.
What's the end behavior of that graph?
4 to 1 or 1 to 4?
Don't get that wrong. Big difference between the two. Big difference between the two. The furthest left is where? Which quadrant?
4.
In quadrant 4. Furthest right is
1.
quadrant 1. So don't get that wrong. It has to be 4 to 1. You go from the furthest left quadrant to the furthest right quadrant. Okay? Yesterday, I gave you 4 characteristics of an exponential graph. What were they? Y-intercept was 1. Domain. Range. And behavior. Notice how they match up. These are inverses of each other. Okay? So you need to be able to remember those 4 characteristics for each of them. You don't even need to remember it. Write it down. Put it on a cheat sheet. You guys see that the other day? Ms. Ludwig left for you. Messages. Okay, explain that to the grade 11s. yesterday, I don't know if I explained it to you guys. Okay, she's somebody that was in here 4 years ago. Sitting in the same classroom, doing the same stuff you are, and there's your tidbits of advice for you. Now she's in university, she's finished her undergrad degree. This is what would help, had she been able to go back and know now, or know then, what she knows now. Those are the important things. She did this on her own, but I wanna leave them with something. There it is. There's how you can be better grade 12 students in this classroom. Fair enough? Okay? Heed that advice. Because I have been telling you this for 3 years now. You don't wanna listen to me? Listen to somebody that's been here, done that. Okay? I get not wanting to listen to me, but listen to that for you guys. The choices are few and far between. Okay, so that's 7.3 and 7.4. We'll work on 7.4 tomorrow. 7.3 we gotta do today. Any problems with 7.1, 7.2? It seemed like you clipped through it pretty good.
Yeah, it's pretty easy.
Okay. Work on 7.3, 7.4 today, please.
I use all two.